Good morning to all for today's session. In today's session, we are going to learn about the role of or the significance of cutoff ratio, which is used in the diesel cycle. Let's go for this session. Cutoff ratio. This cutoff ratio will be used whenever the cycle is becoming as diesel cycle only, not in auto cycle or Brayton cycle. Okay. So first we should know what are the processes involved in the diesel cycle. Okay. So I will give you the diesel cycle. In this, the processes involved are 1 to 2, which is adiabatic compression cycle or adiabatic compression process, and the next one is 2 to 3. This is a constant pressure heat addition. 2 is suppose heat supply, and 3 to 4, which is adiabatic expansion process. Okay, then 4 to 1. The 4 to 1 is constant volume heat rejection process. Okay, so these are the processes involved in the diesel cycle. Okay, it is a closed one. Okay, so for that we have to draw the PV diagram. Okay, now PV diagram is drawn in this pressure versus volume. Okay, so usually the process first one is adiabatic compression. Next one is constant pressure heat addition process. Okay, so this is constant pressure heat addition process. This is 1 to 2. This is 2 to 3, and 3 to 4 is adiabatic expansion. So adiabatic expansion becomes a curvature like this. So this is 3 to 4. Adiabatic expansion. This is constant pressure. Pressure is very constant. Is heat addition. And finally, this 4 to 1 is constant volume heat rejection. So it will be a vertical one. Okay. This is a heat rejection process. Once again, I will explain. 1 to 2 is an adiabatic compression process in which the pressure is increased, so that pressure going on increasing as well as the volume gets decreased. Then in 2 to 3 process is a constant pressure heat addition process where the heat is applied. Okay, we are supplying the heat through the fuel, but here the pressure is maintained constant at the same time, volume gets increased. Okay, whenever if you increase the pressure, the temperature also going to increase. If you increase the temperature, what happens? Volume also going to increase. For that, at constant pressure, okay, pressure is maintained constant, but volume going on increasing here. And 3 to 4 is an adiabatic expansion process. It's an adiabatic expansion, so volume gets expanded. At the same time, if volume gets expanded, what happens in the pressure? The pressure will come decreasing. So that the pressure goes downward direction. So volume going in the horizontal direction. So it goes on increasing volume. Then 4 to 1. It's a constant volume heat rejection. Let's come to the point. Constant volume is here volume in the x direction. So volume is a straight line. The volume at 4.4 plus volume at 0.1 both are same. At the same time, the heat rejection happens. So the temperature will be going down. If temperature comes down, what happens in the pressure? Pressure is also going to decrease. So that is the concept, through the concept only we are drawing this PV diagram. Then I will come to a point. Here the cutoff ratio. Okay, here the topic is cutoff ratio. What is cutoff ratio? Okay. Generally, this cutoff ratio is represented by the letter O. Okay. Then there is a point. It's called cutoff point. Where cutoff means you know that the fuel is going to be cut off. Okay. Where the fuel is cut off, where in which process you are applying the heat, the process 2 to 3. Here the process you are applying the heat. Okay, it is cut off at point 3. Then it goes to another process. Okay, so it starts with point 2 and ends with point 3. Cut off point means point 3 is the cut off point. Cut off ratio. Cut off ratio means the volume ratio. So where the fuel is added, and during the process we have to have a volume ratio. The volume is increased here. So the volume ratio 2 to 3 process heat supply process. So V3 by V2 is the cutoff ratio. Okay. Whenever this cutoff ratio is increasing or decreasing, what is the significance? The significance of cutoff ratio is the main important thing. If cutoff ratio increases, the efficiency of the diesel cycle will come down. Vice versa. If cutoff ratio comes down, the efficiency of the diesel cycle goes up. Okay, this is the significance of cutoff ratio in diesel cycle. Okay, have you understood? Okay. At the same time, we have a cutoff ratio as well as the compression ratio also there, which has been discussed in the area process also. Compression ratio increases, the efficiency of the diesel cycle goes on increasing. Okay. At the same time, the cutoff ratio, the significance of the cutoff ratio also we have to know. Okay. Cutoff ratio means we are cut off the fuel, so the efficiency of the diesel cycle will come down. Okay. So that's all for today's class. We will have another session in the next class. Okay. Thank you.